Hi, my name is Saad, and I will be presenting the paper Design and Evaluation of Hybrid Search for American Sign Language to English Dictionaries, Making the Most of Imperfect Sign Recognition. Sign languages are visual languages, produced by movement of face, hands, and body. Not only deaf and hard of hearing people use these languages, but other people like parents, relatives, and caregivers of deaf and hard of hearing people, as well as students and teachers in different sign language classes, also use these languages. Unfortunately, though, compared to other dictionaries, the current ASL to English dictionaries are less usable. ASL lacks a writing or a standard clause-based system. There's also no one-to-one correspondence with English. But yet there are other issues with existing dictionaries that contribute towards these dictionaries not being very usable. Broadly speaking, there are two types of ASL to English dictionaries. Feature-based ASL dictionaries require user to submit a query by specifying different features of a sign, for example, location, movement, or handshape. There are other commercially available systems that provide the user with more sophisticated interfaces, such as the one here you see on the right side, which provide users with a keyboard to make these queries. However, these interfaces are often complicated to use, especially for novice learners who do not know these different features. There's also poor matching of features to signs, and overall these interfaces are cumbersome to use. The second main type of dictionaries are search by example dictionaries. These dictionaries allow a user to record a video in front of a webcam or a Kinect in order to make a query. There are also specialized gloves or sensor-based input methods that the users can use in other systems. However, recognizing 3D structures of an ASL sign from 2D videos is a difficult task. This is due to the complex linguistic organization of ASL. There's also a chance that the user might not submit a good quality video, which can lead to poor results. So ASL lookup is difficult. Search by example dictionaries make the query process easier, but they use sign recognition technology that gives imperfect results. So users still often have to browse through a long list of results in order to find the one that they are looking for. So what can we do as HCI researchers here? So we conducted two studies to see if there are other aspects of ASL dictionary design that we can improve to improve the user satisfaction with these systems without improving the accuracy of underlying sign recognition technologies. So the things that we looked at were how to present the text or video content in these dictionary systems, and also if we can use post-query refinement methods, for example, filtering, to improve the user satisfaction with these systems. So in our first study, we conducted interviews with ASL students to get their feedback on different aspects of the design. We employed both deductive and inductive approaches for coding these interviews and developed a deductive coding framework, which had three different things: presentation of video results, presentation of textual metadata, and presentation of filtering options. Two researchers then performed thematic analysis and organized the resulting themes into this framework and extracted the final themes. We were able to get some rich data on these three different aspects that I talked about. So participants mentioned different things like how would they want the visual content to be, how would they want the description of each sign to be listed with the visual content, and what kind of filters would they want to see in a filtering interface. So based on the thematic analysis of this qualitative data, we were able to extract 6 different design guidelines that future designers of these systems can use. These design guidelines span the 3 deductive coding categories that we mentioned earlier. For example, the first one here has to do with the presentation of visual content. So participants said that they would like their videos to be played automatically in a simultaneous and looping manner in the search results list. They also liked the textual metadata, and they said that it should be based on the linguistic properties of the sign, and it helped them with filtering of the results. The last 4 design guidelines here have to do with filters, what terminology should be used for filters, and how to present them graphically. We then included these design guidelines in a prototype. For example, here on the screen, on the left side, you see filtering options based on different hand shapes that are graphically represented. On the right side, you see all the results animating at the same time, which was a guideline that came out of user data. We call our final search system with filtering options a hybrid search system. We then wanted to see if there are differences in user satisfaction and task performance between the hybrid search system and the search by video system. We also wanted to see what are the challenges that users face when they use with these two systems, and how are they making use of the different system features. For this, we conducted a lab-based visit-of-awe study. We merely mimicked the performance of an underlying sign recognition system and asked the user to view stimuli video, record their sign, and interact with the results page. This was a between subject design in which there were a total of 20 participants, 10 participants in each group. Each participant performed a total of 32 searches, and afterward they answered these Likert scale questions which are listed in this slide. We also looked at their task success and the time it took them to complete a search. I will now present some results. So the user preferred the hybrid search interface with filtering options, and they reported better search experience when interacting with that system. They also thought that they had greater sense of control over what was happening when they were using the hybrid search interface as opposed to search by video system. For more results, please refer to our paper. We also got some more qualitative feedback. So users in general reported that they experienced a lack of confidence while producing the videos in order to make search queries in both the systems. However, they experienced more challenge when browsing through long list of results in case of search by video, which was the prototype without the filtering options, as opposed to the one with the filtering options. We also got some data on how they use the filtering options. For example, they use the filters after doing an initial scan through the results, and they found handshape to be the most useful filter. So to summarize, we identified and evaluated an effective interface for viewing search results in a sign language dictionary. We also found that there are differences in the way that users like their results to be presented in a sign language dictionary as opposed to in general video-based search engines. We also uncovered several different perspectives of novice ASL learners regarding how they want these systems to be designed. We got 6 design guidelines that can be used by designers of future commercial systems. We also found out that by adding filtering capabilities, the user satisfaction can be significantly improved even when the underlying performance of sign recognition technology was exactly the same. So in our paper, we also talk about how our findings can be generalized to other linguistic and non-linguistic contexts. So for example, future researchers can investigate if people would like to search for Mandarin Chinese characters by writing them or by using voice, which could be followed by a filtering step. And the same goes for searching for videos within data sets of human movement, for example, dance moves, martial art moves, or exercise moves. And that can also involve a post-query refinement method like filtering at the end to improve the user experience. I would like to thank my co-authors, Akhter Amin, Alexis Gordon, Sooyeon Lee, and Matt Huenerfauth from the Center for Accessibility and Inclusion Research at Rochester Institute of Technology for working on this project. The work was supported by a National Science Foundation grant. With that, I would like to conclude my presentation. Thanks for listening.